All right, we're going to do a confidence interval for the population proportion, sample proportion, PP hat world. We're doing problem number 19 from our chapter review. And basically, the first question in number 19 asks us to compute the estimated standard error for the level of support of the L party in 1996 and interpret the value. The L party is right here. We know that the p hat for the L party is 413 out of 1183, and they happen to nicely tell us that that is 0.349. So to find the standard error, I'm going to take 0.349 times 1 minus 0.349, and I'm going to divide by the sample size, which was 1,183. And if I calculate that, using my calculator, I would have 0.349 parenthesis 1 minus 0.349 close parenthesis divide 1183 close parenthesis after putting it all under a square root sign. That gives me 0.013858. So this would be approximately 0.014 if we rounded it to 3 places. Now we're supposed to interpret what that means. Well, what is a standard error or a standard deviation? It's the standard amount that something deviates from a statistic of interest. Our interest is the party support. So basically what 0.014 means is this is the typical amount samples of size 1,183 will deviate from the true population proportion, which shows the support for the L party. And we don't really know what that is. So 0.014 is the typical amount samples of size 1,183 will deviate from the true proportion of support for party L. Okay, now they want us to construct a 95% confidence interval for the N party. So P is my parameter, which is a row this time. This is the true population proportion of support for party N. I guess I should say support level. And basically I am taking that right from here. In, of course, 1996 if I want to be exact. Now I need to test my assumptions. First assumption is that my sample is a random sample. It says below are the results of a poll conducted in 1996 for the 4 political parties. So I'm going to have to say assume p hat is from a simple random sample. So master p hat is an unbiased estimator of the population proportion row, which we have already defined up in the P part of PANIC. Okay, now I'm going to take N, which is 2.11 up above, and I'm going to do 0.211 times 10 is 21.1, which is greater than 10. And then 1 minus 0.211 times 10, and that will equal, and I'm not doing this part right, so let's start all over again. I'm going to take 211 times n, which is 1183. So 0.211 times 1183, that equals 249.613. That is bigger than 10. Now we'll do 1 minus 211, 0.211 times 1183. And that is equal to 933.387, and that is greater than 10. Please notice that if you were to add up your two results, that should equal 1,183, or your n. So what does this tell us? So this tells us, so the sampling distribution is approximately normally distributed. Okay. And the last one, 1183 times 10 gives us 11,830, and we're going to assume that that is less. Assume less than the total population of supporters for party N. So the sampling distribution standard deviation is going to be the square root of p times 1 minus p, and I need to do p hat because we're in the real world. We don't know our rho, divided by the square root of n. All right, name the test. The test is going to be a z interval for a population proportion. I don't need degrees of freedom because I'm not in the t distribution. Calculate the interval. The formula for the interval is p hat plus or minus z star times the square root of p hat times 1 minus p hat divided by n. I already know my p hat is 0.211, and I am doing a 95% confidence interval, so I know z star is 1.96, and I'm going to do 211, 1 minus 211 over 1183. So we have 211 plus or minus 1.96 times the square root of 211 times 1 minus 211 divided by 1183. I get 0.01186 for my margin of error, which is not the same as part A because that was for a different party. Then if I take that times the 0.196, I have 0.02325. I'm going to store that in my letter M. So I can do 211 plus M and get the top of my interval to be 23425. And then if I do 0.211 minus my margin of error, I get 0.187748. And I'm going to check that with my stat test. So I'm doing a z interval. I don't have data, I have statistics. And I need to try a different test, stat test. I want to do a 1 proportion Z interval. I'm doing proportions, not Z. So I know my N was 1183, and how many people voted, or how many people were for party N. Let's look up here. The count was, I believe, 250. So bring that back up. I get 250. And I'm doing a 0.95. So I'm going to calculate that. And that looks rather familiar. We see our 0.211, which is good, since that's what we were using. And so finally, my C. I am 95% confident that the true population proportion of support for party N is captured by the interval 0.18806 to 0.23459, and I would want to put that in percent, so I could do 18.8 to 23.46%. All right, the next thing it asks us is, let's see if I can find it, to if they select people using a random digit dialing, why doesn't the polling organization just ask people in the nearest shopping center? Well, that would result in bias and undercoverage of people who don't shop at that shopping center. The convenience sample will not represent the voting population, and having bias means it will not hit its mark with the p-hat, which we are assuming at this point is around 21% of the population supporting party N. All right, good luck tomorrow on your test.